Okay, this video tutorial looks at the mathematical strand of real number, and more specifically, we're going to focus on our understanding of rates. Now, what you need to understand about rates is that they are essentially the opposite to ratios, right? So rates, or a rate, is an ordered comparison of quantities that are different, all right? Remember that ratios were actually an ordered quantity of the same units. A rate is actually when you're comparing different units. So as we've just stated here, that rates are a comparison of different quantities, all right? Different quantities, not the same. So that's how they differ to ratios. So rates are not written with our ratio sign. Remember that ratios were written as in 2 to 1, okay, with a little double dot. But rates aren't done like that, all right? So that's actually incorrect for a rate. A rate would be using words such as per or a symbol like a divide symbol. So it might be meters per second or meters per second. It might be kilometers per hour or kilometers per hour. Okay. Another example is heart rate. Heart rate's measured in beats divided by time. So it is beats per minute. All right. So we've got per here or beats per minute. Beats per minute or beats per minute. Okay, speed, we've just talked about at the top, is measured in distance divided by time. So it's kilometers per hour or kilometers per hour. Talking about speed, we can use a following formula. So speed is actually equal to the distance something travels over the time it takes. And using this formula, we can work out different problems involving speed. For example, if a car drove 2 hours and covered a distance of 140 kilometers, how fast was the car traveling? Well, the car speed was traveling for our distance, which is 140 kilometers, and it did it in 2 hours. Now remember that this sign actually means divide. So our speed is equal to 140 divided by 2, which is 70 kilometers per hour. Now we can also use line graphs to help us calculate rates, and we can do this because a line graph compares two different quantities. You can see here we got time, and it's actually been cut off here, but this is distance, and it's in kilometers. We are comparing time and kilometers. So for example, using the above line graph, we can determine how far a car has traveled in 4.5 hours. We go across the hours till we get to 4.5, then we go up. Once we hit our line graph, we then find the equivalent spot on our other axis, so our y-axis, and that's going to tell us we're actually at 225. So this tells us that our distance is equal to 225 kilometers. Now we looked at speed and using a formula, and we looked at line graphs comparing rates, but here we're talking about density. Now density is another rate that compares mass and volume. So density is written as mass per volume or mass divided by volume. So if we're going to write that, density equals mass over volume. So for example, if a cube of gold measures 5 centimeters, measuring 5 centimeters, has a weight of 75 grams, what's the density? Now remember that, how do we work out the volume of a cube? Well, volume of a cube is length times width times height. So in this particular case, it's 5 to the power of 3. So our volume is going to be 125. It has a weight of 75, so that's our mass. So the density equals our mass, in this particular case, is 75 grams, over its volume, which is actually 125 centimeters cubed. We can actually cancel this down, and we end up with a density of 3 over 5, grams per centimeters cubed, which is 0.6 grams per centimeters cubed. Now, sometimes we want to be able to convert between rates as well. This is the last thing you're going to need to know about converting about rates. So a common example of this is speed. Now, speed can be measured in kilometers per hour, but it also can be measured in meters per second. Now, in order to turn it from meters per second into kilometers per hour, we times by 3.6. Therefore, if we're going the other way, from kilometers per hour to meters per second, we actually divide by 3.6. Now, sometimes it's much more important to have it in kilometers per hour, and other times it's much more important to have it in meters per second. It just depends on the context of your actual question that you're doing. Okay, so now I'd like you to have a go at some practice questions. When they come up on the slide, if you could pause the video, have a go at them. When you think you've got them correct, continue, and we'll see how you went. Okay, so as stated, here are the practice questions. Please feel free to pause the video, and when you think you've got them all correct, continue the video and we'll see how you went. Okay, so let's see how you went. Now, the first question says, what is the average speed of a cyclist who rides 240 kilometers in 8 hours? So this is going to be our distance, and this is our time. Now remember that the formula for speed is speed equals distance divided by the time. In this particular case, our speed is going to be our distance of 240 divided by our time of 8, which is actually going to give us 30 kilometers per hour, because our distance is in kilometers and our time is in hours. In our second question, it says in 2013, Adelaide's population was 800,000. In 2015, it will be 1.2 million. What is the rate of growth for Adelaide? So in other words, how many people per year? Now you can see that the actual growth of people is 1,200,000 take 800,000, which is going to give us a growth of 400,000. And this happened over 2 years, because we've got 2015 take 2013. That's going to give us 2 years. So the rate is actually people per year. That means the people, so 400,000, so our rate is equal to 400,000 over 2, which gives us an answer of 200,000 people per year. In our last question, it says a cheetah runs 92 kilometers per hour. What is this in meters per second? Remember that kilometers per hour, converting to meters per second, you actually divide by 3.6. So if we go 92 divided by 3.6, that gives us an answer of 25.56 meters per second, and this has been rounded to 2 decimal places, so 2 dp.